So in the series of learning programming in C, we are discussing some special pointers in C. We have discussed void and null pointer. In this video, I will talk about dangling pointer. Everything about this pointer, like what is dangling pointer, the cause of dangling pointers, and how to get rid of the situation, how to get rid of dangling pointers, and if dangling pointer comes in your program, then what type of error you can get. We will discuss with the help of program, or you can say with example. I will show you code also on my laptop, right. So now let's see what is this pointer. Before going to the definition directly, I just want to show you one example. Here I am going to use dynamic memory allocation using malloc function, right. Suppose here I am taking a pointer int asterisk ptr and dynamically I am going to allocate memory here, right. So suppose I am allocating memory here, this would be syntax of malloc function, and here suppose I am writing size of int. If you are not getting this syntax, it's okay, we will discuss everything about malloc and calloc in later videos. For this video, just you have to understand this thing. I am going to ask from the malloc function, right, this is built-in function, that please allocate me a memory dynamically. Dynamically means from heap, right. How much memory? Size of int. Size of int means 4 bytes. Means 4 bytes. Allocate me 4 bytes. And malloc return void pointer. But that is why I am typecasting it. That is why I am writing here int star. Right? Because pointer is what? Type is what? Int. So that is why it is returning void pointer. So I am typecasting it into int. Right? That's it. This is the meaning of this line. Dynamically we are going to allocate memory to pointer, and suppose here maybe in this memory now in asterisk I am storing 10, right. So here it's like something like this. Here we have ptr, and dynamically suppose memory has been allocated and size of int, that is 4 byte. So you can say 4 bytes, 1, 2, 3, 4, and address is suppose 100, 101, 102, 103, and it will return void pointer, but I have typecasted it, so it will return what? Obviously the base address of the first byte. So 100 has been stored in, the address of the first byte has been stored in this pointer. Now pointer is pointing to this memory location. I hope you got the meaning of this line now. Now in asterisk ptr means value at this is, I am accessing value at this point. In pointer I have 100, so value at 100 means here I want to store. So I am not representing it something like this. I am representing it with single block size. Address is 100. So I am storing here 10. Right. Now if you want to print like printf, and I just want to print asterisk ptr, whatever the value I want to access this value, so it will give you 10. Right. But if after this I have done something with this pointer, and after this I want to free this ptr, it means it is basically used to free the memory. Means we have freed this memory. Now there is nothing here. We have freed this memory, right. We have deleted this memory space. We have freed this pointer. But still, yeah, in pointer we have 100, that is address of this, in pointer we have, but actually we have deleted this memory, right. This is no more reserved now. It is in what? Free block of the memory. One is consumed, one part is consumed memory, one part is free memory, right. When you run a program, then obviously some memory has been allocated to you from stack also, and if you allocate memory dynamically, then from heap also. So here we have two parts, free memory and consumed memory. So once we have freed this block is now in free memory, right. So and before freeing this it was in consumed one here. So at that time it was having some valid address like 100. But we have now freed this, so now it is in free block, and all the memory block here are having invalid address, right. But this pointer is still pointing to here. We haven't updated this thing. So now at this time, this pointer is acting as dangling pointer. So now it is what now? Dangling pointer. Here if you will dereference it like printf %d and after freeing if you will dereference it, it means value at this address, but here we don't have anything. We have deleted this address with this memory space. So it will give you some garbage value or maybe some undefined behavior it will show, unpredictable behavior. We cannot say, maybe program will crash or it will give some garbage value, we don't know, because it is now dangling pointer. Dangling is what? In simple terms we will say like it's hanging, it is still hanging, right? But we don't have anything here. Let's take one example. If you have, suppose if you have phone number of your friend, but he has changed his phone number, but you still have that old phone number, right? So that phone number is like a pointer. You can access your friend using that phone number. You can call your friend using that phone number, but now that phone number doesn't exist because he has changed his phone number. So now that phone number is now, it's like dangling pointer, right? You cannot access, you cannot call your friend using that phone number now. If you will call, then what would happen? We don't know. Maybe that has been allocated to some other person, right? Or maybe that is switched off of, or we don't know, anything can be possible. So here also maybe this memory after some time, maybe that freed memory has been allocated to some other process or some other variable or some other kind of thing, and after that later if you will dereference it, definitely it will show some undefined behavior or it can cause some bug in your program, right? It's like risky for your security purpose, right? So don't leave any pointer hanging or dangling pointer. So what is the situation? How to get rid of the situation? After freeing this, what you can do? PTR is equal to null. Better to initialize PTR with null. So now in PTR we have null, that is 0. Now null pointer we have already discussed. Now it is pointing to, it is not pointing to any valid address, and we cannot dereference this null pointer. And obviously a good practice is what? Further, if in a program you will use, first of all we will check if like pointer is equal to null, simply print, we cannot dereference it, else what you want to do with that pointer you can do. So that is a good practice. Before accessing, before dereferencing any pointer in the program, better to check if pointer is null or not. If null, we cannot dereference it, otherwise your program is going to be crashed, right? So this is one reason why dangling pointer comes. This is what you can say deallocation of memory, or you can say distraction of objects, right? So it means what you can say, dangling pointer pointing to a freed memory location, right? Because this has been freed. So a pointer which is pointing to a freed memory location, that is known as dangling pointer. That's it. Right? I hope you got the definition of dangling pointer now. One more reason why dangling pointer comes in your program is, one reason is this, right? Because you have dynamically freed the memory and pointer still exists, right? One reason is this, and how to get rid of the situation, you can point it to null. Second is what? In main function I am taking a pointer, right? And here maybe we write down some code, and within this code I am taking a block, like again curly braces, int a is equal to suppose 9, and within this block I am saying PTR is equal to address of a, and within this block I am just printing a is equal to, and I am accessing this a using PTR. So here it will print 9. So this is the block, right, where I am using this a variable. So a is what now? Local variable to this block only. You can say this is the scope of this a. Out of this scope, if you will use this a, then it will give error because it is local to this, right? Here only you can say A would be created. A is having 9 and some address also, suppose 1000, and PTR is global, not global but within this main function. So throughout the main, this program you can use PTR. So in PTR now we have address of A, that is 1000. So PTR is now pointing to this A, right? And here if you print asterisk PTR, 9 would be printed. But after this block, as soon as control will go out of this one, this would be vanished. If after this you will printf, like directly I am printing A, you cannot access A here, it will give you error. You are accessing a local variable, it will give you error, right? And after this also, if you use like asterisk PTR, then also it is acting as a dangling pointer now, because out of this block now A has been vanished. There is no A now, but this PTR is still pointing to this memory location, but there is nothing here that has been, you can say, vanished. So this pointer is now, it's like hanging. So this will act as a dangling pointer out of this scope, right? Yeah, sometimes still if you run this, still maybe for a while you can get 9. Maybe you are thinking that it's wrong, but it's okay. Maybe for a while, for some time you can get correct output 9. It shouldn't give 9 because now 9 is no more here, A has been vanished, it should give any garbage value, but maybe you can get 9, you can run it and you can check it. But after some other function call, after some time, maybe this memory has been in stack, because when we run a program, then some memory has been allocated, right, to main function. Obviously that would be copied to RAM, main memory. So this, for A also some memory has been allocated, for PTR also some memory has been allocated, for A also memory has been allocated. This is what within this scope only. Scope is this one. Out of this would be vanished, right? So maybe for a while you can get 9, same output, but after some time, after other function call, after in your program, this memory maybe will be allocated by the operating system to some other variable, to some other function. Then if you will dereference it using this pointer, it will give some garbage value, right? But yeah, it will act out of the scope as a dangling pointer, right? And third reason may be like before this main function I am taking one function like f, and I am taking here A is equal to 10, and here I am return address of A. This function is returning address of this variable, right? And within main function what I am writing, so it is returning address. So to catch address, to store address of any variable, we should have some pointer variable. So here I am having pointer variable, and whatever this function return, f return, that would be stored in this pointer, right? It is returning address, so that is why it is int star asterisk, right? So it will return address, and this pointer is going to store that address. And within main function I am writing, like I am dereferencing this asterisk PTR, like whatever the value at that address, it should be printed, like it should be printed 10, because it will return address of A. So in A we have 10, so it should print 10. But here this PTR is acting as a dangling pointer. Why so? Same, this A is within this function, so scope of this A is within this function only, right? Now it will return address of A, but after returning, as soon as control will go out of this function, this A would be vanished, it would be deleted. So now here this pointer is, obviously it has returned the address here, right? So in PTR we have address of A, but as soon as control will go out of this function in the main function here, because I am calling function here, when the control will go out of this one, this would be vanished. So now what, this pointer is still hanging, because whatever the address it is containing, that is no more now, that memory is now freed, it has been vanished, right? So now also it is acting as a dangling pointer. and if you will like dereference it, maybe it will give some garbage value to you. And see here, if because this scope of this is within this function only, but if you declare it static, static variables are having scope what globally means throughout the program. So if you will declare it static, then it is not going to vanish. It will return address of this A, and if in main function if you will dereference it, it will give you 10. Now it's fine. Now it is not acting as dangling pointer, right? Because we have used static here. This also we'll discuss in detail, but for this video you have to take have to understand this thing. Static variables, these are having scope, you can say globally or throughout the program, right? So now let me show you practically what is dangling pointer. So now let me create a file. Header file we use, and we also use one more header file, that is stdlib, because here we use like for that malloc function, dynamic memory allocation, and that is built-in function that has been defined in this header file stdlib, right? So first of all I am taking like that same one pointer, and dynamically what we are allocating memory using malloc. So size of int, and we have allocated like the memory, so that in that memory I am storing 10, and I am printing %d. I am accessing that thing using that memory using pointer only, right? So I guess it should print what 10 if the syntax is correct. So let's see what happens here. See, it is giving output 10, right? So now what I am doing, now free the memory, whatever the memory pointer is pointing, free that. This is the syntax of this free function, free, and just you have to pass the pointer which is pointing to that memory location. So that memory has been freed, like vanished, but pointer is still pointing to that. So now pointer is acting as a dangling pointer. So now if you will access this like printf, again here I am using asterisk ptr. What it should give, we don't know, maybe it will give some garbage value. See, 10 first time, and after that it is giving some garbage value, right? And suppose again run this, at this time again some another value, garbage value, right? So this is what dangling pointer. So how you can get rid of the situation? After freeing directly, simply do ptr is equal to null, and we cannot dereference null pointer, so please don't dereference null pointer now. Before dereferencing in a program, good practice is what? Use check if this is null, pointer is null, you cannot dereference it, else you can do whatever you want to do with that pointer. So one situation is this. Next can be like I am just going to comment this out, right? And next we are using that function, right? So before using this main function, what I am defining a function f, and here I am taking a variable int a is equal to 9 and return what? Address of a. That's it. And in main function what? We will take a pointer, because to store address obviously we need a pointer variable. So whatever this function will return, this pointer is going to take, right? And after that we are printing, I am writing this line like printf %d and asterisk ptr. So I am accessing this ptr now, right? So let's see what happens. Let me run this. See, it is not returning anything, like no output you are getting, and the function returns address of a local variable, address of a is local variable, right. So here this PTR is acting as a dangling pointer, you are not getting any output, right. Maybe sometimes it will give any garbage value, it depends, we cannot say, it will show some unpredictable behavior, right. And next is what, if I am taking a pointer here, right, suppose pointer is equal to, so better to initialize a pointer at starting. When you take a pointer, better to initialize it with null. So if you are not initializing here with any valid address, so better to initialize it with null. So next case is, I am not taking this function now, I am deleting it. So PTR is equal to null, and here I am taking like within this block I am taking a variable a is equal to 5, and here PTR is equal to address of a, and I am printing printf a is equal to whatever the value a is having. I am accessing this using PTR, so asterisk PTR, right. Suppose this line I am going to comment it out, right. So this is what we have, see, this is what we have, right. So what output you will get? Obviously you will get 5, right. See, a is equal to 5, but out of this block, this is the scope of this a. If out of this, using this printf statement, out of this block I am accessing asterisk PTR. Now here it is acting as dangling pointer, so it will show some unpredictable behavior. Maybe your program will crash, or it will give some bug, or it can create some bug, or it will give some garbage value, we cannot say. But sometimes it will give the same value, that is 5. It is also possible. See, let me run this and see what happens. Okay, just a minute. Now let me run this. See, a is equal to 5, for this a is equal to 5, and this printf is also giving you 5. But although the scope of this a is within this only, it has been vanished, but still it is giving you 5. It is also possible, for a while this will give you correct output, but after some time when you write some other in your program, maybe that freed memory location would be allocated to some other function or some other variable. So after that this pointer, this line, this pointer will show, it will not give you correct output, it will show some unpredictable behavior, right. So this is also fine. Maybe you are thinking it is giving 5, so it is it is not correct, but no, yeah, it can give you some correct result for some time, for a while you can say. So that's it for this video now. So I hope you got what is dangling pointer in C. We are left with one more pointer, that is wild pointer in C. So now that thing we'll discuss in next video. So I'll see you in the next video. Till then, bye bye. Take care.